Hello, ladies and gentlemen. This is Daksh Bhagwani, and I am here with my team, Bharat Kumar and Keshav Gehlot. Myself, registration number 017. Bharat Kumar is 020, and Keshav Gehlot is 034. We are here to present Computer Network Unit 5. We have chosen topic of transport and application layer protocols. So what we are going to cover today, let's take a brief view of what are the things we have divided in this particular slide and the presentation. It includes the application layer. What is application layer? How does it works? Second are main core concepts, which will help you clear out what is the difference between UDP and TCP. Next comes DNS protocol. Giving a brief, it is basically how the domain names are being generated and given to the IP addresses. Next comes HTTP protocol. It is a foundational thing of web communication and data exchange. Next is email protocols. We have been using emails throughout our journey from, let's say, class 5 to colleges and corporate world everywhere, right? So we are going to take a good depthful drive over it. Next is ending with FTP and Telnet. So let's understand first what application layer is. So you might have heard about the OSI layer. So application layer is the top layer of the network model, which helps the user application to interact with the server and with other applications. Now, for an example, take example of Google, right? The user interface you have been seeing for searching the things, for clicking on the links, everything. It stacks on the top of the layer due to the application layer. Now, this runs on specific protocols and services, such as it is needed to be controlled by the World Wide Web. There are certain web documents, web servers, which we are going to see in the last part. But what are the key characteristics? So, first, it helps us to interact, it helps the user to interact. It provides end-to-end services in order to connect to the servers and the services. Third, with the help of the protocol, it helps us to connect and implement other services, different services. And last but not least, it helps us to just simplify the complex network. Now, let's understand a very small, brief architecture of how the client and server communicate. So, a client requests a particular service. Let's say I searched on Google for something, let's say SRM University. So, it will give all the results which is there in the database, there in the server stored from Google. So, it will give all the results regarding the same search result which I have searched. Right. So what it does is it initiates the communication. It helps us to give and provide all the documents and services which are there in the server. And it can be either a active document or a static document, which we are going to see in the last part. So now what server does is it has stored certain files, documents which are being provided to the client using different algorithms, different interpreters, right? Such as you have seen HTML, GSP, XML, etc. So that all helps us to give a user interface, to provide the user a user interface to interact with and see the documents with ease. Now, port numbers. Yes. So you have heard about port numbers being a 16-bit integer number, but it sounds boring, right? So let me help you out with a very simple example. So let's say that we live in a flat and every flat number is different, starting from 1 to let's say 65,535. So each port number defines different house or different services running. Let's say on the house number 1, there is cooking services. On house number 80, let's say there is services for computer fixing and everything. So that kind of different services are being provided to the port numbers. For an example, port number 80 is already occupied or is requested for HTTP services, 443 for HTTPS services, port number 21 for FTP, 22 for SSH, and so on. Well, the list is endless, but in order to simplify all these things, we have divided into three parts, which we are going to see right now. Okay, so the three parts are first the well-known ports. Let's understand what is the range. The range goes from 0 to 1023, and in between these range, there are some preoccupied and common reserved ports which are assigned by the Internet Assigned Number Authority, which is INA. Right. So, as I gave an example of port 80 being used for HTTP, 443 for HTTPS, 21 for FTP, 553 for DNS, and so on. Next are the registered ports. These registered ports range from 1024 to 49151. So these can be actually used by any other services if you want to host. Let's say 3306 is used for SQL or MySQL services. So you can use these ports as they are not reserved and you do not need any permission to run any service on this ports. Next are the dynamic or private ports. These are used mainly for very temporary purposes of communication, and mostly when a client or server wants to connect temporarily for quick data to be assigned automatically, and it ranges from 49152 to 65535. Next is two transport layer options, which is UDP and TCP, which is going to be explained by Bharat Kumar.
Hi guys, myself Bharat Kumar, register number 020. I'm here to explain TCP and UDP protocols and introduction about the DNS. There may majorly two transport layer options are there. Before application data can be transmitted, it must be one of the two transport protocols. Each offers a different balance of speed, reliability, and complexity. Those two are UDP and TCP. UDP stands for User Datagram Protocol, the fast and simple service. Like sending a postcard through a mail, no connection setup is required, no delivery is guaranteed, but incredibly fast and efficient. It's best for speed critical applications where occasional data loss is acceptable. TCP, Transmission Control Protocol, the reliable and orderly services. Like sending a register package with a tracking requires connection setups, guarantee deliveries, and ensures all pieces arrive in the correct order. It's best for application where integrity and reliability are essential. UDP, User Datagram Protocol. What are the key characteristics of it? It should be connectionless, no handshake or connection setup required before transmitting data. Unreliable delivery does not guarantee order delivery or the datagrams will arrive at best effort only. Simple and fast, minimal overhead with a fixed 8-bit header, making it extremely efficient. Stateless. Each datagram is independent, no connection. State maintained between sender and receiver. Transmission control protocol. Transmission control protocol is one of the core protocols of the internet. It operates at the transport layer and provides reliable connection oriented communication between devices before sending data. TCP establishes a connection through the process known as a three-way handshake, ensuring both sender and receiver are synchronized. TCP breaks large messages into small packets, numbers them, and ensures all packets are received and reassembled in a correct order. Once a TCP strong features is error detection and recovery. If packets are lost, duplicated, or damaged, TCP automatically retransmit them. It also performs flow control, using the sliding window mechanism to ensure that a sender does not overwhelm the receiver, and conjunction control to prevent network overload. TCP operates in full duplex mode, meaning data can flow in both directions simultaneously. Common applications that rely on TCP are web browsing, email, FTPs. The protocol ensures that users experience smooth, complete, accurate data delivery even over complex networks. In short, TCP prioritizes reliability and making it deal for applications where accuracy and integrity are more important. TCP and UDP differences. TCP and UDP are the two primary transport layer protocols and each serves a unique purpose. TCP is a connection oriented, ensuring a reliable connection before data transmit. begins. It guarantees order delivery, performs error checking, and retransmit lost packets. In UDP is connectionless and much faster because it doesn't establish any handshake or perform extensive error checking. Data is sent as independent packets, meaning some may out of order or get lost without being retransmitted. The simplicity makes UDP ideal for real-time applications like online gamings, voiceover, IPs, and live streamings, and TCP connection, three-way handshake. TCP connection, three-way handshake. Before data transmission begins, change the slide. TCP connection, three-way handshake. Before data transmission begins, TCP establishes a connection using three-way handshake. This handshake ensures that both client and server are ready to exchange data, agree on initial sequence numbers, and synchronize connection. The process involves three essential steps. Synchronize SYN. The client sends a synchronization request to the server to initiate a connection, proposing its starting sequence number. Syn ACK means synchronize acknowledgement. The server responds by acknowledging the client request and sending its own synchronization signal back. Acknowledge. The client acknowledges the server response, completing the handshake. After these three steps, connection is established and reliable data transfer begins. This method guarantees bidirectional readiness, preventing data from being lost or misinterpreted. The three-way handshake also provides a layer of security and reliability, verifying that both systems are active and reachable. If any message is in the process is lost, the connection is not established until the successful retransmission occurs. Visualization of three-way handshake. The three-way handshake can be better understood by and observing the roles of the client and server in the process. On the client side, the process begins in the send packet sent to server requesting communication establishment. The client then waits for a response. The server side always listening for incoming request receives this send and responds the packet acknowledging receipt and signaling readiness. Finally, the client send back the acknowledgement confirmed to successful synchronization and data transfer. And then synchronous exchange ensures both the parties agrees on the sequence numbers and prepares to handle data reliably. However, during the waiting period between the SYN and ACK messages, the server temporarily stores the half open connection in the queue. Attackers sometimes exploit by sending numerous fake SYN requests, causing SYN flood attacks, a form of DOS attacks, denial of service attacks.
Human remembers name, but not the numerical IP addresses. DNS is a distribution hierarchy database that acts as an internal phone book. It translates human domain name into machine readable IP addresses. Also, we use cache to store the recent uplift, which speeds up the future request to an to the same domain. Second, how DNS works. DNS works in multiple steps process. The initial step, it asks the local DNS server what is the IP address of a particular website. Here, we take an example of SNMISC.in. The root server query. It resolves the first ask. The root server. The root server replies, I don't know, but I know who handles .in and goes to the .in TLD server. TLD server query resolves and asks the .in top level domain server. It replies, I don't know, but I know who handles .edu.in. Go ask them. Second level domain query resolves ask .in server. It replies, You need to ask authority server for srm.isc.in.edu. The authorized authoritative answers the resolve query dot srmisc.edu.in. The authorized server. This server has an extra record and replies the IP address in numerical form. Correction. The result gives the IP address to the computer which can now be established a direct connection. Web and even protocols. World Wide Web is a massive system and interconnect of multimedia documents linked by hyperlink. HTTPS HTTP stands for Hypertext Transfer Protocol. The application layer protocol that defines the rules of how a web client and web server communicate. Key features of HTTP is that it is stateless. This means each request is treated as an independent transaction. The server doesn't remember the past request from the same client, which simplifies the server design. This mechanism like uses cookie-less sessions in the stateless HTTP. HTTP request response and cycle. The basic conversation bit for loading a web page. Client requests the browser and sends HTTP request, which includes HTTP line, header, and body. HTTP line is like slash index.html. Header contains the browser type, except the language. The body contains the data for the post request. Server response. The server processes the request, sends back the HTTP response, which includes status line, header, and body. Status line contains http.p00. If it's okay, it sends successful, or if not found, it gives errors like 404 not found. Header contains type, content length, and cache rules. Body contains actual content, HTML, images, and all the other requirements to load a web page. Common HTTP status codes are good by their first digits. 2xx successful, for example, 200 is okay. 301 moved permanently. 404 not found is a client error. And 505 tells you there is a server error. HTTP connections evolve effectively. Non-precedented HTTP like /01. This was the original method. A new TCP connection was required for every single object. A page with 25 and images need to be loaded with the three-way handshake, making it a very slow. Resident HTTP, HTTP slash dot one dot default. This solves a single TCP connection. It opens and uses the request multiple object sequences. This eliminates repeated handshake, making the page load much faster, reduces server load. Modern HTTP or HTTP plus 2 and HTTP plus 2. Improve this further with features like multiplexing, sending multiple requests at once over the connection. Email architecture protocol. Sending an email informs three main components: user agent, message transfer agent, message access agent. User agent, your email client like Apple Mail, Gmail, its interface is used to read and compose messages. Message transfer agent, MTP, the mail server, does the heavy lifting by pushing the email from the server to the recipient server across the internet. Message Access Agent or MAA manages your mailbox on the server. It pulls the protocol POPC or IMAP to retrieve the email from the server to the user agent. Push versus pull. Push protocol, simple transfer protocol. SMTP is used executively for sending email. It pushes the email to user agent to your server and then from your server to the recipient server. It uses TCP port 25. The pull protocol retrieves your mail. POP, Post Office Protocol. This is a simple download and delete module. It downloads your mail from the server to your device and then typically deletes from the server. Limitation. Your email only exists on one device and there is no synchronization. Internet Mail Access Protocol. This model synchronizes your email client with server, message, and folders are kept on the server. Advantage. You can access your email from multiple devices like phone and laptop and etc. All the changes are synchronized everywhere. This is the modern standard. File Transfer Protocol. FTP stands for transfer large files between client and a server. It was designed to solve problems transferring files between different operating systems, which may vary file naming, conversion, and dictionary structures. HTTP most unique features it is a dual connection architecture, control connection and data connection. This remains and can establish the first opening to the entire session. It is used only for sending commands like user, pass, list, and receiving responses like 200 OK, 404 not found. Data connection is a separate connection opening for each individual file transfer, uploads, and gets the dictionary list. It transfers the actual data content. It closes immediately after the transfer is completed. Note, on the security S standard STP insecures the model and encrypted. Alternatives include SFTP or SH transfer protocol and FTPS secure. Telnet. Telnet login protocol. Telnet allows a user to access a control remote computers as if they were sitting at its terminal. Every keystroke is sent to the remote system. This output is sent back to your display. It is used concepts called net virtualization technique to ensure compatibility. The client converts the local keystroke into synchronization NVT. The format the server translates the NVT format into commands. It owns the OS understanding. There is a security flaw in this. Telnet is extremely insecure. It transmits all the data, including username, password, in a plain text. It is highly vulnerable and intercept. Secure Shell is a modern encrypted replacement and should use all the remote access. Now that is gonna sum up the video.
Ladies and gentlemen, this is the time where we end our presentation with the summary of what we have seen in the past few slides. So yeah, first we went through the application layer, which was a small brief of how the client server architecture works, how the data has been transferred, how the web documents can be accessed. Next was explained DNS, domain name system, in which we went into a brief but depthful way of understanding how the domain name systems, the domain names are being assigned to the IP addresses, and how the domain names can be accessed, which redirects us to the IP addresses directly. Next is HTTP. HTTP, as we saw, that how the web pages, resources, how the message cycle works, and a lot of things. Next was SMTP. As we know, SMTP is Simple Mail Transfer Protocol, which is being used mainly for pushing all the data from the mail servers to the client server. Next is POP3, which is Post Office Protocol, and it is helping for us for pulling out the request from server to the client with help of simple download and delete model. Next is IMAP, which is Internet Mail Access Protocol, which helps us and users to provide an interactful interface as well as help syncing the email by managing the messages directly on the server. Along with that, we saw a few extra points on IMAP, including how it helps us in managing, sending, and renaming the files in the email system. Next comes FTP, which is File Transfer Protocol. We have seen that how it is reliable for transferring bulk and larger amount of data rather than comparing to the HTTP protocol. Next is Telnet, also called Terminal Network, which helps us connecting to remote login through other devices or operating systems. So that's it for this particular presentation. Thank you so much everyone for joining with us in this presentation and slides. Thank you.